Hello, everyone. I'm Seth Grimes. I'm very pleased to be presenting to you today as part of the NLP Summit on natural language processing for subjectivity and emotion. Thanks very much for inviting me to present John Snow Labs. It's a pleasure. So myself, I'm a consultant through a company called Altiplano Corporation. I write on natural language processing, text analytics, and applications, and particularly over the last 10 or 12 years on sentiment analysis and on emotion AI. That is technologies that detect and make use of emotion in all sorts of sources. I also run a few natural language processing meetups, and I'm very glad that I've had participation by David Talby from John Snow Labs, Washington, D.C. Natural Language Processing, and New York Natural Language Processing. So my talk is on natural language processing for subjectivity and emotion. Yeah, we're talking about use of technologies to understand human communications, but more than just straightforward communications, the words that we speak, how we deliver our thoughts and our feelings. So we recognize that there is facts and there are feelings that, and all of those things are important. The topic of emotion, well, it's been studied by philosophers going back thousands of years. I have on the screen now a couple of images from 400 years ago by a French artist and architect, Charles Lebrun, who sketched out as studies for the paintings that he did facial expressions of emotion. And if you read French, and you can see in the slides his labels there, you can see how he classified them. There's a certain principle underlying this of universality of emotions, but that's something to call into question as we look at AI. We understand also that emotion is conveyed in speech and text. So let's look at a couple of examples here, just pulled online. We have a review of a hotel where we have really someone who's quite angry, a one-star review labeled atrocious. Who cares what I saw here? The experience was awful. We have expressions of emotions here. And then we also have Twitter emotion, where the person is directly using emotion terms, angry at Trump, lying, and so on. So we have explanations for emotional feelings. And then we actually have an emotion action here, which is the act of sharing how one feels. So these are important clues that can be used for any number of business applications. And by business, I mean something very broadly. It can be used for what's called customer experience, for market research, for consumer insights, to figure out how people are feeling about brands and interactions with them, but also very importantly for other reasons. One is indicated on the lower left of the slide that I have up right now, looking at emotion indicators of suicide potential. We can look at indicators of post-traumatic stress disorder and so on in order to identify cases and to study diagnoses and so on. So we have a whole range of motivations for trying to get at the emotional content, the subjective content, how one feels, how one is induced to feel in all sorts of media, including text and speech. The topic of emotion AI, really what we're studying here, in particular AI for text, the first trace of that I can find dates to 2008 from the site that you can see here, Expressi, a cloud platform naturally, to try to understand emotion. This particular effort didn't really go anywhere. Yeah, sure, we have loads of initiatives that don't go anywhere, but they advance an overall field. That overall field, emotion AI, is really rooted in something called affective computing. Affective computing was pioneered by Professor Rosalind Picard at MIT. I will read from the quotation that I have on screen right now, where Roz said in 1997, if we want computers to be genuinely intelligent, then we need to, if we want them to adapt to us and interact naturally with us, then we will need the ability to recognize and express emotions and to have what has come to be called emotional intelligence. So we want emotional intelligence in computers. Here's an image from Roz's book from 1997. I'll be a little bit familiar because I actually know her and had her speak at a conference that I produced a number of years ago. So you can go out and find Roz's work at MIT. She's actually focusing mostly on wearables for detection of body states as advanced indicators of seizures. So that is something very much related to that. The work that she has done in affective computing is something that has precedent, for instance, in educational studies. Here's a slide of Bloom's taxonomy of educational objectives dating back to 1956, where there's a distinction between affective, cognitive, and psychomotor states as educational components. So we understand that cognition, that is rational reasoning and so on, is somehow distinct from affect, how one feels, one's internal emotional state, and that in turn is related to psychomotor, the motions, and which both express emotion and are related to our feelings. Going back even further, another few hundred years, we have the French mathematician Blaise Pascal, who very famously said, "Le corps a ses raisons que la raison ne connaît point." The heart has its reasons that reason knows nothing of. So our goal here is to apply machines to detect and understand those hidden reasons that the heart has, that is emotions and feelings. And our method here is to construct models and then apply them through artificial intelligence systems of one type or another. That can be for chatbots and so on, or it can be for data analysis systems. It can be for robots that we seek to have convey emotional states and perhaps even hold those states themselves. Who's to say that we can't have machines in the future that actually have something that is similar to human emotional states? So we're talking about models. We're talking about efforts that are really in their very early stages. So here's where I bring up the famous quotation from the statistician George Box: "All models are wrong, but some are useful." I will posit to you, I will assert to you that the emotion models that we're playing with here are not perfect. There are a number of assumptions that underlie them that are not necessarily 100% foolproof and bulletproof, but they're useful. They're useful in trying to understand how people are feeling in their expressions on social media, in conversations, in all sorts of other media. So what sorts of models? Well, here's an example. This is one that comes out of the University of Geneva in Switzerland, the Geneva Emotion Wheel. If you look at the individual dots here, we have textual labels for different emotions. This comes with the proviso that I have in the quotation and an abstract from this paper, which talks about certain limitations and so on. But without dwelling on that further, we want to get directly into the how and not just the models. All the same, I'll continue on models to look at one that is extremely popular, the Plutchik's model of emotions. It is laid out as a star here, with the red represents anger, rage, and so on, different forms of that. The green represents terror, fear, apprehension. These things are compositional. They can be added together. Emotions are complex. People can hold multiple emotional states at the same time. That is both the people who are experiencing emotions and the people who are consuming, who are in communication with people who are experiencing emotions and are trying to understand them. The right side of the slide here, the wheel diagram, is a different representation, a projection, let's call it, of the Plutchik star. So there are a number of ways of representing what, again, are models of emotion understanding. How do humans experience emotion? Another representation of the Plutchik work is something that's out of Centric Net. This is work of Dr. Eric Cambria and others in Singapore. You can go find it online. Centric Net has been around for quite a number of years, a dozen years or more, and started out looking at sentiment analysis. The quotation I posted here, combining common sense, reasoning, psychology, linguistics, and machine learning. Well, call the latter parts here, linguistics and machine learning, call that computational linguistics. That is something very much akin to natural language processing, but there are divergences in certain ways that maybe will surface in the next few minutes. So I said that Centric.net has been around for maybe a dozen years, focusing originally on sentiment analysis. Let's look at sentiment analysis and then compare it to emotion AI or emotion language processing, if you prefer, in this context. Here's a paper from 2003 and another one from 2008. 2003, sentiment analysis, capturing favorability using natural language processing. So we do have roots here that go back, in this case, 17 years of trying to apply natural language processing to understand sentiment in text. On the right side, opinion mining and sentiment analysis. Some people see opinion mining as a synonym for sentiment analysis. So what is sentiment here? Here's a slide from Bing Liu, who is at the University of Illinois in Chicago, laying out a representation, not as a Plutchik-style graphic model, but rather something that one might have in a computer, a tuple. So we have a target for emotion, and Bing identifies this as something extractable using natural language processing, named entity recognition, named entity extraction in particular. I will say that in the years since 2010, we're looking at emotion not only, well, sentiment in this case, not only for named entities, but for other types of things. For instance, we can try to ascribe an emotion to an event, which is not a named entity, but it is something else that can be extracted from textual and other sources via natural language processing. We have emotion at so-called at other types of levels, at facet levels. For instance, a hotel room might have a facet of the temperature or the bed comfort or the size or the price for that matter. So we have so-called aspect-based sentiment analysis, not just named entities. We have the features, but we also have a sentiment determination. Sentiment analysis, that's typically positive or negative, but then we also look at when the sentiment was extracted and expressed, because sentiment can change over time, of course, including for a given opinion holder. So we have other elements of natural language processing that apply here as well to further refine our sentiment analysis. Another slide from Bing. This is going forward a few years, updated in 2015 and 2020, looking at emotion, not just sentiment, but a similar type of model, but understanding that we're not looking only at positive, negative, neutral assignments, but also at fear, anger, happiness, joy, apprehension, emotional states. Now let's talk about a subjectivity type of question here. Well, I have an image of a basketball player. This is Kobe Bryant, who was killed in a plane crash. It elicited a lot of sadness just a year ago, but he looks quite happy in this photo, doesn't he? So we understand that emotions are complex things. You can be proud, you can get a lot of joy out of Kobe Bryant's career and his charitable works for that matter, and still feel very sad about it. So emotion, well, it's a positive sentiment to feel sad about Kobe Bryant's death. At the same time, the sadness is seen as a negative emotion. So there's a lot of complexity here. So looking just in a few bullets at the bridge between sentiment and emotion, we understand that both are subjective states where the opinion holder might have a different feeling from the person who is expressing the opinion. Just as Kobe Bryant is smiling and is happy in that photo, we feel sad. Emotion models may be fine-grained, they may be hierarchical. Yeah, we might talk about 6 basic levels of emotion, or we might talk about 60, where there are refinements on the 6 basic emotions. The categories aren't orthogonal. We can have emotion is compositional. You can feel multiple things at the same time, a mixture of emotions. And the feelings are situational. They depend on very much on the context, and the sentiment in particular, it can't be mapped in a one-to-one manner to a given emotion. You can feel sad and that can be positive. So let's go on to some actual examples, and I will have a disclaimer here, which is that I'm going to use a lot of commercial products to illustrate concepts. These are only illustrations, they're not meant as representations. So part of this is, well, why create my own diagrams when others have done a very nice job for me? Let's take a couple of 3 diagrams here to look at the diversity of emotion sources from Ipsos, which is a market research firm, from Census, which is a solution provider, Sensum rather, a solution provider, and so is Crowd Emotion. We understand that emotion can come from facial expression coding. That goes back to that Lebrun stuff that I showed at the beginning from 400 years ago. It can come from measuring body states, my heart rate, and my eye tracking. What am I paying attention to? And does my attention linger on something? It can take a look at the rapidity of your breathing. And not only at a heart rate and rapidity of breathing, but how that changes. We can obviously analyze voice. I'll get into that a little bit further later. And as I showed already, we can study emotion in text. So emotion AI in general has really 3 aspects. One is understanding emotion in whatever the source is, whether it is images, facial expressions, text, or voice, emotion understanding. Next is emotion synthesis. How can we get machines to convey emotions? Whether they are bots, for instance, or maybe even robots taking some sort of human form. And then there's emotion induction. How can I get you to feel a certain emotion? Can I get you to feel nostalgic or angry by conveying something? Anger is a convenient emotion to evoke if you're in a political setting, for instance. So now let's get into the how you do it, focusing on text and then on speech, since this is a natural language processing context. The first way that people often approach these problems is by creating lexicons. I have an example here from the National Research Center in Canada, a work by Saif Mohammed. It's very useful. You can go find it online yourselves. He has done extensive work, he and his team, in creating sentiment and emotion lexicons. So we assign a particular word, angry, that appears explicitly in a text, a certain emotion classification within the models of the sort that we have already described in this talk. Another representation of Saif Mohammed and colleagues' work from the Canadian National Research Center. Here a diagram that shows prevalence of emotions according to different categories in a familiar type of visualization here. And he has in particular, if you look at the textual part to the right of this slide, a sentiment, emotion, sentiment assignment for different emotions. So abandon is negative, for instance, abhor is negative, but as I indicated earlier, sometimes this isn't so simple. Sad may be a negative emotion offhand, but when you're considering sadness about the death of someone like Kobe Bryant, then it is a positive emotion because you're feeling positive about him and his contributions. Looking further, here's some work that's done in R to study statistical characteristics of emotion appearing in text, emotion words, that is. We have plenty of online systems that will do this for you. I've mapped out a dozen or more readily available as a service emotion classifiers via application programming interfaces. IBM's Tone Analyzer, part of Watson, is a very notable one where we can supply text to the system and it will do emotion extraction and do assignments for particular entities that appear within the text. So go out and find it yourself. There are online examples that you can play with to study this. That's the great thing. It's very accessible for just trying things. Here's a different type of corporate example. Clarabridge is in the customer experience space. They're known for their text analytics capabilities. And we have visualization of emotions felt by customers with different types of associations. So we see how this stuff, how these engines produce data that can be used to visualize, to create insights for customer experience, market research, and other types of business functions. Here's yet one other example. As I said, these are meant as illustrations. While the core.ai example here is labeled sentiment analysis, it does look at what I would call emotion terms. So there's a bit of fuzziness here. Yeah, we understand between sentiment and emotion, but we understand also that sentiment, as classically used, that word does encompass feelings and emotional states. So words, however, aren't everything. I talked about lexicons to start this section. We understand that words aren't everything. We have idiom. For instance, Alyssa Milano posts a video of Trump and Hillary Clinton from a debate 4 years ago, where Hillary Clinton is warning us about what Trump is all about, in other words, himself. And she posts, just going to leave this right here. Actually, there's no emotion content in that text if you just read it straight, if you read what is literally written. But just going to leave this right here is an emotional conveyance. It says you should look at this, and it expresses disdain toward the subject of what's being communicated here. And in fact, I didn't just put up Alyssa Milano's tweet, I put up a retweet of it, a share by someone who calls himself ex-Trump voter. Hillary Clinton was right. He's making it very explicit here. So we have a communicative act, a social act of sharing. So this action, even though it carries no words at all, conveys a certain emotion of agreement, and it is an amplifier of the underlying emotions that were being conveyed in the thing being shared. So we need to look not only at the words, but also at the actions, at the conveyance here. Maybe a linguist, or rather a scientist, would call this the pragmatics as opposed to the linguistics of the thing. We have to understand the personalities involved, because the personalities matter. If Trump says something, it's very different from if Hillary Clinton says something equivalent, because we understand their personalities. And further, we can go ahead and create personas, that is, classes of personalities. We understand the different aspects of the medium. When something does something on Twitter or Facebook, that carries a very different type of context, including subjective context, from when it appears in the New York Times, or particularly when it appears in the New York Times editorial pages versus in the news pages. So here's another slide from Bing Liu talking about some of the linguistic complications of emotion in text. I'm not going to read this, but he talks not only about emotion words, direct emotion words, but intensifiers, very, so, extremely, and so on. So we have an intensity of emotion. We have behaviors that involve emotion, someone crying, well, that indicates an emotion, even though there's nothing in the word cry that says, yeah, this person is sad. We understand the emotional association of the action, the behavior. We have differences, superlatives versus comparatives, more, better versus best. So superlatives put something at the top of the stack, and so on. We have other ways of conveying emotion, for instance, via swearing, foul language, and so on. I don't even include here punctuation marks. If I follow something with 6 exclamation points, that is emphatic, it's an intensifier. If I put in a emoticon or an emoji that is frowning, that indicates a negative sentiment. Let's go into speech, which is another aspect of natural language processing, not directly text. We understand, however, that speech, what I'm doing right now, I'm speaking in words, and my words have a certain punctuation to them, everything that we've been talking about so far, but speech is more than just text. Speech is also intensity. I can speak very loudly, I can speak very rapidly, I can pause. I might repeat myself. If I repeat myself multiple times, that's something that I'm really emphatic about, just as yelling is something that is emphatic. And pauses can indicate uncertainty. It can indicate disdain and so on. There are extra textual clues like sobbing that indicate emotion. So we have emotion in speech, in the speech act, in everything that surrounds the words as well as in the words themselves. How do we apply this? Well, we're interested in voice bots, and the principles that I'll show in these next few slides apply to text bots as well, to conversational AI, both in voice and textual forms. We want to understand what someone is trying to convey, not only the intent, what that person wants to accomplish, what that person is saying in words, but also that person's emotional state. Because, for instance, if someone is communicating with a bot and is getting angry, then we want to respond in a calming way, or perhaps we want to escalate the call to a human operator. So emotion is important when it is appearing in conversational AI, both in our response, the bot's response, and in also the bot's understanding. We want to render emotion in more mundane settings when interacting with devices such as an Amazon Echo device or a similar device from other providers. The emotion conveyance in Amazon Alexa right now is limited to markup. It's not something done via AI, but it's something that is evolving. We have voice rendering of emotion. I have a picture from a paper from a few years ago here from 2018, voice conversion for emotional speech. We have rule-based synthesis. Well, rules underlie a lot of classical natural language processing, but we are understanding that the rules have a big place here, but also deep learning and methods that build emotion models in hybrids with rules-based systems. Conversational AI, we understand that there is a lot of factual information out there that doesn't directly involve emotion, that not everything is emotion, that we need to understand emotion in conjunction with natural language processing that gets at the factual content of all of our sources. So we do want to look at voice utterances, at speech, also not just as with text understanding through online services, through APIs. They can be engines that are installed. We have those out there. Oliver API, Speech Emotional AI, is an example there, where we can look at different emotion states. Another is Amelia AI from IPsoft. Again, these are just examples meant to perhaps inspire you at your use of natural language processing to get at emotional states and not just at factual information in the diversity of content that you are trying to analyze, whether speech or text or the combination. And that wraps up what I have to say to you. So I hope this has been very useful to you to give you a basic understanding of emotion text, emotion speech, that is emotion natural language processing, the models that underlie the understanding of emotion in general, how computers can adapt these models for computing using rules-based systems, using deep learning, using any other kind of methods, how you can create the models and then you can deploy them for analytical systems, for instance, for customer experience, or for automated interactions via automated conversational AI, via bots and so on, and then eventually via robots that simulate humans that can augment our abilities to communicate. So I find this a really important field, and I would love to talk to you more about it if you're interested. The easiest way to find me is via Twitter or online in some other way, and I look forward to interacting with you further about this. Thanks for attending my session.